Okay, so Pre-Calculus 20, this is the chapter, 6 review. So we're going to go over a few questions here together. This is 6b. It says, simplify, determine all non-permissible values for the variables. Were there any of these questions that you guys have tried and had trouble with? Any of these ones that are up on the board right now? Anybody want me to do one of these over the others? Okay, seeing no hands, I will just pick one myself. Let's do the first one. Determine all non-permissible values. Okay, so when we're asked to determine non-permissible values, that means that we're looking for values for x that cause the expression to be undefined. And most of the time, what we're looking for here is we're looking for what x values make the denominator 0. So in question number I here, number 1 there, we want to find out where 3x plus 2 equals 0, because that's the x value that is non-permissible. And so I would encourage you to set it up like this. We know that this denominator, and there's only one binomial factor there, that cannot equal 0. So we just treat this like an equation. And 3x cannot equal negative 2. X cannot equal negative 2 divided by 3. All right? So that's the non-permissible value. There's only one for that one. If we go down to, let's say, the third one, non-permissible values, again, focusing on the denominator. So 4x minus 4y cannot equal 0. What you might want to do is you might want to factor this. Okay, so take out a 4, and then you'd see this. That's a bit easier to work with, because now you take each factor separately, and each of those factors, or neither of those factors can equal 0. So 4 is easy. There's no x or there's no y. There's no variable there. So there's no restriction attached to just a plain old number that's a factor. So you don't even have to worry about this one. I'm just going to X it out for now. But you want to focus on this one. Okay? This cannot equal 0. So what can x not equal? Well, we solve for x in the normal way. And we see that when we add a y to both sides, that x cannot equal y. And y cannot equal x. Really, that's saying the same thing. So these are the restrictions. Y cannot equal x, and x can't equal y. Because if they were to be subtracted, you'd have a 0 there. Okay? So you can just write that once, I guess. I just rewrote it the other way so you can see that there's actually two restrictions, right? One on x and one on y. All right. Any problems with that? Okay, I'll let you work on the other ones if you wish. Let's move down to the next one here that I have prepared. This one simply says simplify each product. So we're simplifying. So we're going to multiply them together, and we're going to reduce the fraction as much as possible, the rational, to get the simplest form. Let's start with something easy. Let's start with A, the first one. Okay? So I have 2p over r times 10q over 8p. What you could do is write all of this on the top as multiplied factors, like that, and everything on the bottom as well as multiplied factors, if you wish. You don't have to rewrite that, but I'm going to show you that these two multiplied together, these two separate rationals multiplied together, can be just squished together as one rational that's multiplied everything on top and then divided by the multiplication of everything on the bottom. So this is what I'm looking at. I'm looking at a factor of p and a factor of p. Notice they're all multiplied, so they're all considered factors. That's why we can divide them out. If there was any plus in there, you can't take one of those little things and divide it out if it's part of a plus or a minus, right? So p and p can go. It looks like I can reduce 10 over 8. So I could divide both of those by 2, looks like. So that 8 becomes a 4. This 10 becomes a 5. Okay, that's one little bit of simplification I can do. I also notice that the 2 and the 4 now can be reduced. This becomes a 1, and that becomes a 2. So before I get too messy here, let's rewrite this. So I've got 1, the 2's gone, the p's gone, the 10's gone. That become a 5, and we've got a q. So I've got 1 times 5 times q, 5q. On the bottom, I've got an r that didn't get divided out. I've got a 2 that didn't get divided out, so I've got 2r. All right? And then the final thing you want to do is note the restrictions. So again, the denominators cannot equal 0. So r cannot equal 0. And then p, right, is in this one. So p can't equal 0 as well. P cannot equal 0. We don't have to worry about this one because it's not a division, right? If it was dividing, you would have to consider the restrictions up here as well. But it's not, so we don't have to worry about that. So it looks like this is your solution. Okay? Any questions there? Maybe let's do a more complicated one. Did I give you any questions from 9 on your review? ACE. Okay. So we could do I could do C or I could do D. D is a little bit tougher. Has anybody tried 9C and had problems with it? Okay, let's do 9C then. Okay, 9C. So simplify and determine non-permissible values. Okay. Let me just get rid of this so it's not in the way. All right. Multiplication, and we've got a factor down here and a factor down here. So remember, you do not have to get a common factor when you multiply. You can just multiply straight across. But we should try and factor the numerators and denominators of everything we're multiplying. We should try and factor those first. So let's take a 3 out of here, and then this becomes a plus b. Does everyone see that? And then I'm going to write a 4 as another factor over there. Okay, so I've got these 3 factors up top here now. And I've got 8 times a plus b. So everything is factored. Because there's a plus sign in here, I have to treat this as one whole factor. I can't. Please don't do this, because I still have kids doing this. Oh, that a goes with this a. Well, if it's part of a binomial or something that has a plus or minus, you can't take a piece out of that. That's kind of like saying 45 divided by 4 is 5. That doesn't work. So it's very similar to doing that. So, but what we do notice is that we have an entire factor, a plus b, that we can get rid of, right? So that's a factor, a plus b with a plus b. So that's gone. And then 4 over 8, that simplifies to 1 over 2. So I've got a 3 times 1. That's a 3. And I've got 2 times, well, everything else is divided out, so it looks like 3 over 2. With a not being able to be equal to negative b, and b not being able to being equal to negative a, looks like. Because I'd simply let this factor not equal 0 and solve for each one. Okay. And it's 9C. Yeah, looks good. Okay. Any questions about 9C? Does that help over there? Yes? Okay. Everybody doing okay so far? All right. Okay, let's keep going. I do have number 10. I have number 10 and 15 ready here, so I'd like to do a couple of those. These are a bit trickier. So from 10, what did I give you? A, C? Probably? So let's take a look at, well, I tell you what, let's take a look at D, and that's simply because it's one of the maybe more complicated ones. So if you can get this one, the other ones are easy. And I think maybe if there's an E, you'd have to do that one too. So 10D, okay. Divide, express in simplest form, non-permissible values. Good. All right. Let's take a look at this one then. So again, you're going to want to factor, probably write as a multiplication, and then note restrictions, and then divide out, and all that sort of stuff. So let's factor first. I'll take a 3 out of this top one. I can't factor this bottom one anymore. I'm going to go ahead and write this as a multiplication right away and do a couple steps at once. That means I have to flip this one, right? I have to flip those around so that a minus 3 is going to go on top. Can I factor this trinomial? You sure can. You should be pretty good at factoring trinomials at this stage of the game here in this class, okay? If you're still struggling with this, you need to do something about it, okay? Because this needs to be pretty automatic here. This is a plus 3 times a plus 3. Okay, it's a perfect square trinomial. 3 times 3 is 9. 3 plus 3 is 6. There you go. Okay, now is a good time to note restrictions before you start dividing things out. So we see that a cannot equal, well, it can't equal a positive 3 over there. And over here, it can't equal a negative 3. So you could probably just go there, plus or minus 3. There's your restriction. Oh, but what else do we need to notice? I need to make sure I pay attention to this top one too, because this was a division. So I need to take care of all of these, which actually this is a positive 3 as well, so we don't have to change anything. But you do have to look at the numerator and denominator of something that you're dividing. Okay. Okay, and we'll keep going to this one. So a plus 3 and one of these a plus 3's is gone. A minus 3 with an a minus 3 is gone. So I'm left with 3 over a plus 3. Any questions about 10D? You guys are good? Okay, let's do something from 15 here now. Did anybody get this far here yet so far and have any problems with 15? A, B, C, or D? Okay, so let's do this, add or subtract. Let's take a look at B. B looks like, well, B or D, I don't know. Let's do D. D is probably the more complicated one, so let's do D. So what are we looking at? We're adding or subtracting, simplest form, non-permissibles. Good. So when you add or subtract, you need a common what? Common denominator, right. So with this one here, again, we're going to do D. We need a common denominator. So I don't know what the factors are with this one, so let's factor everything and find out exactly what we have. So remember, factoring top and bottom is always it's always the best place to start. So take an a out of there, factor this trinomial here, that's going to be a plus 3 and a minus 2 because those two multiply to negative 6 and they add up to positive 1. Now, do not do this. Oh, hey, I've got an a plus 3. I can start canceling out something. No, don't do that. We're not canceling anything out because we have to get a common denominator and combine the two terms because it's subtraction, not multiplication. So I see over here I have an a plus 3 times an a minus 2. And over here I just have an a plus 3. So this one needs an a minus 2 so that they're both the same. And what I do to the bottom, I have to do to the top. Now I have a common denominator of a plus 3 times a minus 2. And I'll just rewrite this so you can actually see it. Notice we're subtracting, so please remember that you have to subtract every term to the right of that minus sign. So that's why I sometimes put another set of brackets there. Okay. So on the top I've got a squared minus 2a, and I've got minus a squared minus 3a. And you do not have to multiply these factors in the denominator out. Just leave them as factors, because we may have to divide. So I'm going to go up here, maybe so you can see all this in one shot here. So a squared minus a squared. You see how those are gone? A squared minus a squared, gone. This right here, carefully, negative 2a minus negative 3a. So that's negative 2a plus 3a up top. And again, if you're okay with doing all this in one step, you don't have to rewrite this, but I'm going to do that so you can see. So negative 2 plus 3 is just a. Okay, and so with that one there, which one was this? D. Okay, so now we have to note our restrictions. This is the answer. That's the simplified answer there. But we have to note our restrictions. So you're going to have to look back and make sure that a cannot equal, well, let's go to this one. A cannot equal negative 3, and a cannot equal, over here, positive 2. So there are your answers there. I mean, that's your answer with the restrictions. Okay. All right, so those are the example questions for the review that I've got for you so far. Let's see, now 6.4, let's do an equation. So we'll do one more from 6.4, and let's do something from, let's do maybe a word problem here. So we'll do number 21 together from your review, and you have to read the word problem, and you have to kind of extract information out of there, make an equation of some sort, and then solve for what you're missing. So this one says the sum of two numbers is 12. The sum of their reciprocals is 3 over 8. What are the numbers? Okay. So it appears that we have two numbers whose sum is 12. And we're given that as our first bit of information. Okay. So you could set up the two numbers as x and y if you want. And this first sentence gives us this information. Okay. Now, what's important though is if we're trying to solve an equation, we want just one variable. So right now we have two, so that's not great. So let's look at what other information is given. The sum of their reciprocals is 3 over 8. Oh, okay. So we're also given this. 1 over x plus 1 over y is 3 over 8. The sum of their reciprocals. Okay, when you flip the denominator and the numerator around. Okay, so what do we do with two equations? Well, we've done questions like this before, not very many, but this is a skill you're going to need to know as we move through into calculus. If you have two equations and two variables, you can combine those into one equation with one variable only, and that's what you want to do. So this one's an easy one to rearrange. Let's rearrange this as y equals 12 minus x. So I'm going to have my two numbers are going to be x and 12 minus x. Okay, does that make sense? If they both add up to 12, x is one number, and the other number would be the difference between 12 and x. And so we want to get one variable only, very important. Now what I can do is I can substitute what y equals here into the other equation and focus on that. So I've now got 1 over x plus 1 over, well, what does y equal? Well, we just said here y equals 12 minus x. And in this way, we're going to focus on this equation that has all of the information in the question, all of it combined into that equation, and we only have one variable. That's what we want, one variable only. So we're going to find x here. We're going to solve for x. So that's half the question right there, is setting up the proper equation. All right, well, we know we need a common denominator, so guess what? I am going to say this side needs a, well, actually, common denominator, remember, actually, you can get rid of all the denominators in an equation. So let's not do common. Let's get rid of them. So let's multiply everything by x, because that's this denominator. I want to get rid of that. Let's also multiply it by 12 minus x, because that's this denominator. I want to get rid of that. And 8 is the other one. So let's multiply everything by 8 as well. So if you do that, you're going to get rid of the denominators. It's going to be a nice, regular old equation to solve. So the next step from there is going to be, when we multiply this first term by all of these, the x's will cancel out. See that? So I have, over here I have 1 times 12 minus x times 8. That's what this times this turns into. For the next one, this now times this, the 12 minus x's, they cancel out. You see that? So I'm going to have 1 times x times 8. And then for this one times all those, the 8's are going to cancel out, and I have 3 times x times 12 minus x. Okay? So I've gotten rid of all the denominators. Now what I have to do is I have to multiply and then gather all the like terms and see what I have and see if I can solve that equation. Okay? All right. So what do I have? 12 times 8 is what? That's 80, 96 minus 8x. Over here I have plus 8x equals, this is going to be 3x times 12 minus x, which is going to be 36x minus 3x squared. All right? So let's pull everything over to the left side. 3x squared is going to come over there as a positive. I'm going to take this, these x's are gone, negative 8x plus 8x. This is going to be a minus 36x. And then do I have anything else? Plus 96 equals 0. So we'll take a 3 out, minus 12x plus 32 equals 0. And we'll solve this quadratic. So if we're trying to find x, we don't have to worry about the 3. You can actually divide 3 out of both sides like this, right? And then it's gone. It's still 0 over here. And if you factor this trinomial, two numbers that multiply to positive 32 add to negative 12. That's going to be negative 8 and negative 4. So the solutions look like x equals 8 or positive 4. So we have to check now to see if those actually are reasonable. So the sum of two numbers is 12. The sum of the reciprocals is 3 over 8. Okay, so x is 8, so that means that the numbers would be 8 and 4. And if x equals 4, the numbers would be 4 and 8. These are not the two numbers. These are the two possible values for x. It just so happens that they equal the two numbers, but you have to be careful with this. X is 8, therefore y is 4. Or x is 4, therefore y is 8. It just so happens that it works out this way for this example. So you might want to just, they're the same numbers, so I guess there's only two options. So let's just check to make sure that works. Okay. Yeah, so if you do a quick check, we'll see that the 8 and 4 are the numbers, and that does work out for both pieces of information in the question. So there you go. Your answer is the numbers are 8 and 4. You want to write that as a sentence. Numbers are 8 and 4.